Thank you very much, Chen. So good afternoon, everyone. My name's Rod Downie, and I lead the Polar Programme for WWF, based in the UK. I'm joined by a really amazing and quite inspirational panel, who I'm going to introduce in a minute. But first of all, just to say it's a real pleasure to welcome you all to this event on climate change and biodiversity. And we're going to focus in on one particularly emblematic species today, the emperor penguin, and how it's facing this potential trajectory towards extinction unless we do something about it. So thank you to those of you who are joining us here in the room in Sharm el-Sheikh, and thank you also for those of you who are joining us online remotely from places around the world as we live stream this event. But you know what, no matter where you are in the world today, it's clear that what happens in Sharm over the course of these 2 weeks is absolutely critical for the future of nature and for the future of humanity. We know that our planet is on the brink of irreversible harm. So over the last 50 years, we've destroyed nature, we've devastated wildlife, we've messed up the climate, which is why we're here in Sharm. We've put the health of people and nature really at risk. And the climate crisis and the nature crisis is here, it's upon us, and it's now. And constantly around the world we're seeing temperature records broken. In the UK where I live, we saw temperatures go above 40 degrees centigrade for the first time ever, or at least the first time on records this summer. And worryingly, our Living Planet report, which is WWF's flagship report on biodiversity, we released it last month for 2022. And it shows that global wildlife population sizes have plummeted by about 69% on average since 1970. 69% decline. I mean, it's genuinely shocking. But we're increasingly realizing that the climate crisis and the loss of nature are not separate issues. They're two sides of the same coin. And we can't tackle one without tackling the other. The good news is that the science is clear. The science is very clear. We can restore nature where it's degraded. We can limit the mercury to rising from beyond 1.5 degrees. But in order to do that, we have to act with absolute urgency and ambition and commitment and justice. And it's clear that the decisions that are made here in Sharm over the course of these 2 weeks, and indeed the actions that follow up post-Sharm, will define our future and our children's future. Now, I have an 8-year-old son, so I'm acutely aware that the next generation will hold us to account. They will not forget. So that's why for WWF, the fight for our world is about so much more than just protecting penguins or polar bears or giant pandas. It's no longer an act of charity for us. We really view it as an act of survival. It's also clear to us that the oceans and cryosphere have a really critical role to play, not only in climate science, but also in climate action. And for far too long, the oceans and the cryosphere have been out of sight, out of mind, and indeed largely absent from many of the international policy negotiations on climate change. But we're seeing change there. The tide is turning. We saw amazing progress in Glasgow at COP26 in terms of integrating the role of the oceans into global climate policy. And we've seen a number of really key reports and compelling, if somewhat worrying reports, coming out from the IPCC and also from SCAR, the Scientific Committee on Antarctic Research, about the state of the oceans and the state of the cryosphere. So we have the science, we have the knowledge, we have the policy tools, and we have the incentives, and it's just time for action and time for implementation. And with that, so enough from me, I'm now going to introduce our amazing panel. So can we bring the panel up on screen, please? Great, here they come. Phew, I can sigh relief now. We've got you all. Brilliant. I'm going to introduce everyone together and then hand over for the presentation. So first of all, we've got Professor Jane Francis. Jane will be up first. So Jane is the director of the British Antarctic Survey, which is a UK government research organisation that focuses on environmental research in both polar regions. And Jane's a geologist by training, with research expertise in understanding past climate change in the polar regions, and her interests now are in how fast these regions are changing today, and how that's going to impact across the rest of the planet. And in recognition of her services to UK polar science and diplomacy, Jane was appointed a Dame Commander of the Order of St Michael and St George. So welcome, Jane. Following Jane, we're going to have a joint presentation from Dr. LaRue and Dr. Stephanie Jenouvrier. So Michelle is a conservation biologist and an associate professor of Antarctic science at the University of Canterbury in New Zealand. And Michelle has a focus on GIS, so geographical information systems, and the use of high-resolution satellite imagery to study spatial and population dynamics across a wide range of species, including emperor and Adelie penguins, through to Weddell seals, and in the Arctic polar bears and muskox. So welcome, Michelle. We also have Steph. So Steph Jenouvrier is an ecologist at the Department of Biology at Woods Hole Oceanographic Institution in the US. And Steph's expertise lies in understanding and predicting seabird population dynamics, including how they respond to current and future climate change. So welcome both, and we're really looking forward to your presentations. And then finally, and last but absolutely not least, we've got Jane Rumble. So hi, Jane. So Jane is the UK's senior polar diplomat. Jane has headed up the Polar Regions Department at the Foreign, Commonwealth and Development Office since 2007. And Jane was awarded an OBE for her services to polar science, marine conservation and diplomacy. And Jane is a geographer by background and a fellow of the Royal Geographical Society, who recently nominated Jane as a geography superhero. So, wow, what an amazing panel, 4 amazing speakers, and I feel very, very privileged to share this virtual stage with you. So let's dive in. Jane, I'd like to invite you, please, to give us the big picture. So help us to understand why Antarctica is so important, and in particular why the ocean which surrounds Antarctica, so the habitat of emperor penguins, is so critical. So over to you, Jane.
Thank you very much, Rod. I'll just share my screen. It says a host disabled participant screen sharing. Could somebody put my slides up? Thank you, Rod.
Okay, Jane, we're on it.
It's okay. I can.
That's fine, Jane. You should be able to share now.
Thank you. Here we go. Right. Can you hear me okay?
Yes, and we got your slides, Jane. Thank you.
Thank you very much. So, as Rod said, I'm going to give an overview about Antarctica's climate change and ultimately lead down to sea ice and the penguins for the other speakers. So, of course, Antarctica is an amazing place, and unlike the Arctic, which is warming very fast, the Antarctic is slower, but it's showing signs of the impact of warming. The Antarctic ice sheets are up to 4 kilometres thick, so there's an awful lot of ice there. It holds 90% of the world's ice, 70% of the world's fresh water. And of course, before the ice melted on Antarctica, in this absolute worst case scenario, global sea levels would rise by 60 metres, and that would have this really would have a devastating effect on the planet. So it's really important that we don't get that far. But before we get that far, we really need to think about how that's impacting a lot of the animals on Antarctica as the melting happens. So a lot of the observations made in Antarctica now are of the whole continent, and they're done by satellite, which is really giving us the bigger picture. What you can see here is a NASA image from the GRACE satellite, which is measuring the loss of ice mass in Antarctica. And on the left-hand side, you can see a graph which shows essentially that the ice mass on Antarctica has gradually been decreasing over the last 20 years. There are, of course, annual variations, but there is definitely a downward trend. Antarctica is losing its ice. And on the right-hand side, you can see the satellite image data, which shows the areas which are losing the most ice. So those are the red areas. And you can see it's the western part of Antarctica, the West Antarctic ice sheet, the western rim, which has the most red on this, and particularly an area around the very dark red, the Amundsen Sea region, which is losing the most. What's interesting also now is that the East Antarctica, you can see there's a growing orange blob on the eastern side around some of the glaciers there. And as you'll see, what we think is happening is that warmer oceans are beginning to get underneath the ice shelves at the edge of the continent. And so we need to think about East Antarctica as well now. So what actually is happening, how is climate affecting the ice sheets in Antarctica? And the first stage of this attack has been on the ice shelves, the ice that flows off Antarctica, and then it flows from glaciers onto the ocean and floats as a shelf onto the ocean. And what we now know is that the ice shelves are beginning to melt, but not from above, but from below. And this diagram is of a UK-US program, one of the largest field programs at the moment, which is going on to investigate exactly that issue, what is happening to the ice shelves in that western Antarctic region. So the Thwaites Glacier, where you can see the red blob on my map of Antarctica, is where that really red area was on the satellite image of Antarctica. And this is where the Thwaites Glacier goes down into the ocean as an ice shelf, and then it's beginning to break up. And the question that this large group of scientists are asking is, what is happening underneath the ice shelf? And you can see it's being attacked by many scientific programs, from aircraft doing radars, surveys from above, there's satellite imagery. There's a lot of camping on both the glacier and on the ice shelf to try and understand what's happening. But most importantly, I think, is the ocean work, large ships in the ocean deploying autonomous vehicles and understanding what is happening to the heat in the ocean, what is happening to the ocean through climate change, and then what is happening underneath the ice shelf. And you can see some of these red lines that are going underneath the ice shelf. And what these scientists have found is that warm water is now being pushed underneath the ice shelf, generated by stronger winds. And the really key thing about particularly the Thwaites Glacier is that they are interested to know if the warm water is going to get as far as the grounding line that you can see on the left-hand side. And if that warm water melts through the grounding line, the glacier and the ice shelf will be lifted up, and warm water will be allowed to go into the West Antarctic ice sheet and melt it from within. And this is one of the major tipping points that scientists have identified as having a drastic effect on our global lifestyles if this glacier melts, if the West Antarctic ice sheet melts. But as Rod said, what we really understand now is that the ocean is really quite critical in what's happening in Antarctica. And the Southern Ocean around Antarctica is a key to a lot of the melting. And this has been studied. There's a report here, particularly in 2019, that looked at the Southern Ocean and the cryosphere, but how the Southern Ocean is impacting on Antarctica. And basically, the Southern Ocean around Antarctica is the largest uninterrupted ocean current on Earth, and you can see from this diagram that it's not just a single current that's flowing around Antarctica. There's a lot of eddies around in the current itself, And those eddies are drawing down heat and carbon dioxide created by humans, anthropogenic created CO2, and heat down into the ocean. It's taking in what scientists have calculated as equivalent to about 36 degrees centigrade of heat being buried in the ocean, taken down in the ocean, and the global ocean. And the Southern Ocean is so important, it's so large and deep that it's taking down about 50% of that carbon dioxide into the ocean. And here you can see a diagram of where it's going, and in particular, the carbon dioxide, the man-made carbon dioxide is being drawn down into the deep, deep ocean depths, and it's being stored there currently, and it could be stored, it's estimated to be stored for hundreds of thousands of years. And one of the issues is what's going to happen in the future as our climate warms more to that heat. Will it be released back into our atmosphere? And that will have a drastic impact on our global climate in the future. And of course, carbon dioxide being buried in the ocean is also causing ocean acidification, which is affecting a lot of the small biota that have calcite shells. So there's a huge impact from this heat and CO2 going down into the ocean currently. A lot of that is generated, caused by winds, and winds are quite important in the story of climate change in Antarctica. And of course, we know now that the sea ice around Antarctica is also quite critical, and this is where the ice story links with the penguins. And the sea ice is this annual ice which freezes each winter, either as drifting pack ice here or as fast ice attached to the coastline. And this is where the penguins, the emperor penguins, breed. That's why it's so important. But the sea ice itself, which needs far more research, I think, to understand it fully, is really critical because it is an insulating layer between that warming ocean water below and the cold air above. And it's one of the reasons why some of that heat is trapped in the polar ocean. It also is quite critical for the global circulation because as the ice forms on the surface, as the sea ice forms, the salty, dense water then flows downwards through into the ocean, and it creates currents which create ocean mixing to bring nutrients up, but it is also an important component of the flow of the global ocean circulation. And it's also, of course, many habitats for many of the polar animals, including the penguins. So the sea ice is really critical for understanding the future of the penguins. And what we've noticed this past year is a really important change in sea ice. So you can see there, sort of bottom left, is a picture of the winter sea ice. So the maximum extent is usually around September, when Antarctica practically doubles in size by sea ice that forms. And then it begins to shrink during the summer, but it doesn't disappear entirely. But what has been happening in this, particularly in this past year, is that the sea ice has reached its lowest extent ever since satellite records began in 1979. And what is happening again, it's the winds that are strengthening around Antarctica, something because of changes in our global climate that's linked to even to the tropical regions. But the stronger winds have blown the sea ice out from most of the coastline and then blown the sea ice into warmer waters at lower latitudes, which has then melted them, except for the Weddell Sea, where the winds have blown the sea ice into the Weddell Sea up there in the top of the picture. So the sea ice is very variable. Some years it's been greater than this, but this is certainly the lowest extent, and it's something that we really need to understand more in the future. And here I refer you to a book, the Antarctic Environments Portal. The Scientific Committee for Antarctic Research, SCAR, has published this amazing report that summarises a lot of the changes in Antarctic climate, which I referred to you. There's an online version, and it tackles sea ice and the potential trends and projections into the future. And that's one thing I think that we really need to question in science: what is happening to the sea ice, what is happening to the surface waters, and then the impact on the global impact and impact on the ocean circulation if sea ice changes drastically in future. And this is where I hand over to my biological colleagues, who are going to talk about why the sea ice is so critical to emperor penguins and to actually the whole food chain in Antarctica, and what will happen if the sea ice really does begin to disappear from Antarctica and have a devastating effect not only in ocean circulation but also in our iconic species of emperor penguins as well. So thank you very much for that. I'll stop sharing and I'll pass over to the next speaker. Thank you.
Thank you very much, Jane. That was really powerful, and I can just sense the audience here have really kind of got the message about the interconnectedness and how sea ice is changing and how Antarctica really matters. So, yeah, as you say, we're going to hand over to Michelle and Steph now. We've actually got a recorded presentation. The time zone simply didn't work. So this is a recorded presentation from Michelle and Steph on the current science around emperor penguins and future projections. So can we roll with the recording, please? Thank you.
Kia ora, tēnā koutou katoa e ngā mana whenua o tēnei rohe, tēnā koutou. My name is Michelle LaRue, and I am a researcher at the University of Canterbury and also at the University of Minnesota. I'm honored to be here to present virtually at COP27 to talk about emperor penguins. My colleague, Dr. Stephanie Jenouvrier, and I Kia ora, tēnā koutou katoa e ngā mana whenua o tēnei rohe, tēnā koutou. My name is Michelle LaRue, and I am a researcher at the University of Canterbury and also at the University of Minnesota. I'm honored to be here to present virtually at COP27 to talk about emperor penguins. My colleague, Dr. Stephanie Jenouvrier, and I will spend the next 30 minutes or so talking about our research and one of our favorite birds in Antarctica, and how changes in sea ice may impact their populations.
Scientists working in different parts of the globe, South America, North America, and Europe. We have heard how this information can be used for the benefit of local communities and the general.
Now, when Steph and I are the ones giving this talk, it's important to know that big research like this is really a team effort, and so we'd like to acknowledge our colleagues from all over the world who lent their expertise and enthusiasm to the work that we'll be talking about today.
Other actors can achieve the sustainable and comprehensive management of this ecosystem.
So you've probably heard that Antarctica is the highest, driest, coldest, and windiest continent on the planet, which really does make it a pretty tough place to live and work, but that's at least for people. Emperor penguins, of course, have evolved for millions of years to thrive in some of the harshest conditions our planet has to offer. And they're singular in many regards. They're the only penguin species that never really comes onto land. They can dive more than 500 meters below the ocean surface, and they can hold their breaths for up to 30 minutes. And they're the only animal that returns back to the Antarctic continent. Now, much of what we do
con el pueblo. Gobierno del Perú. Tierra solo hay una.
Good morning. I will
Kia ora. life cycle of the emperor penguin begins in March or April every year. This is right as the winter is setting in, and this is just after the fast ice, which again is that frozen ocean water that happens to be attached to the Antarctic continent. It's right after that has formed. And so this is when the birds congregate at these colonies to find their mate and to breed. The female then lays a single egg in mid-May, which is what this picture here is showing you. So this is a picture of 2 emperor penguins, and this is the female laying her egg right there. So this egg will be incubated by only the male, while the females then leave the colony to the nearest open water, either in the polynya, which is that open water in the ice, or traveling all the way to the edge of the fast ice in order to forage. Then, by the time the females return, the males have fasted for more than 4 months and lost almost half of their weight. As the winter then turns to spring and the chicks get bigger, both parents then take turns going back and forth to the ocean to forage. In September, then the young emperor penguin chicks are left entirely alone at the colony so that both parents can forage together to satisfy the chicks' needs. And then by December, when the summer is in full swing, everybody will have left the colony. So there's only one thing to remember about the life cycle about the emperor penguin, at least for this presentation, is that there's a delicate balance between having enough sea ice to live on, but not so extensive that the walk to the ocean becomes too long. The duration of their foraging trips between the colony and the nearest open water really depends on the extent of the surrounding ice cover and how far away water openings are from the colony. Now, much of what I've just discussed comes from what we learned at only a few colonies, but keep in mind, Antarctica is very big, and it's the highest, driest, coldest continent on the planet. Now, about 10 years ago, we discovered that we could actually detect and count emperor penguins using high-resolution satellite imagery. This is the kind of imagery exactly like you might see on Google Earth. And this is the kind of technology that's advanced our ability to learn about them across the entirety of their range rather than just a few locations that happen to be close to research stations. So how critical has this satellite imagery been? Well, up until about 2010, we thought that there were about 30 colonies of emperor penguins in Antarctica, which is what you see here with those orange dots. All of those are places we knew where emperor penguins had lived previously. But by using satellite imagery, we have discovered another 30 colonies or so, and some of which you see here as blue dots. And so all of those little blue dots are places that we never knew existed prior to the advent of satellite imagery, or this higher resolution satellite imagery. So now we have a much better idea of where all the colonies are located, and interestingly, this technology has also offered some important insights to their behavior. So for example, we now know that in years of poor sea ice formation, if it's too thin or if it doesn't form quickly enough, emperor penguins at a handful of locations can actually climb up onto the Antarctic continent or onto a nearby ice shelf. And this is what you see here. This is a high-resolution satellite image of an emperor penguin colony. And normally the birds are out here on the sea ice. But on this particular image, you can see that the guano stain is right here and the main colony is right here. And that's actually up on the Nickerson ice shelf. Now, prior to using high-resolution imagery, this is something that we didn't know happened before. And so what you can see here is that normally the birds are on the ice, but clearly here they're on the ice shelf, and that's something we just didn't know that they had ever done before. High-resolution imagery has really been a critical advancement in our understanding. Another interesting fact that we've learned is that sometimes entire colonies will disappear in 1 year and return in the next, or maybe they'll disappear over a couple of years and return sporadically. And so if you look on the left-hand side of this screen over here, you will see a small brown stain, and that the red arrow is pointing to, and that's an emperor penguin colony at this place called Leda Bay. So this whole place is called Leda Bay. And this image was taken in the year 2010. But if you go to the right and look at the image of Leda Bay the next year in 2011, the colony is entirely gone. It's the same place, but the birds were there in 2010 and gone in 2011. And so this yo-yoing between presence and absence of entire colonies is something that we call blinking. And it seems that some colonies do this more so than others, but we still don't know why they do this. Like, why do these birds sometimes show up and sometimes they don't? We just don't know the answer to that question yet. And finally, we can use these images to train a computer to tell the difference between penguin pixels and pixels of snow and of their guano. And combining that information with aerial surveys, ground counts, and effectively everything else that we can think of that we know about emperor penguins, that information allows us to monitor their populations because we can actually transform the area of penguin pixels into a population estimate. And we can do this at every single colony throughout Antarctica. And that allows us to figure out how they're doing and if changes in their habitat or in the Southern Ocean might be having an influence on their populations.
We need to address the question how sea ice is influencing population fluctuation. And this figure shows the fluctuation of emperor penguin at a colony in Terra Deli in East Antarctica. And we have data since the 1960s where we can see that at the beginning of the time series in the 60s, early 70s, the population was quite stable, fluctuating around 6,000 breeding pairs. And when the population suddenly decreased by 50% in the late 70s, early 80s. And the population have relatively been stable since then. And this dramatic decline in the population coincide with several consecutive low sea ice years in Terra Deli. So to be able to understand better the demographic mechanism by which sea ice affects the population, we build a demographic population model that includes the effect of sea ice on survival of male and female, as well as the mating processes. So to be able to understand better the demographic mechanism by which sea ice affects the population, we build a demographic population model that includes the effect of sea ice on survival of male and female, as well as the mating processes. So the first question, why was the population declined by 50% during the 70s, early 80s? And the answer is the population declined because the adult survival of male declined as well tremendously during that period. And we have shown that sea ice is affecting negatively the survival of male in Terra Deli. The second question is why the population did not recover after this decline in the 70s, early 80s, while adult survival have increased to the previous level. So using demographic model, we have shown that the reason why the population did not recover is because the average breeding success declined over the study period and its variance increases. What happened is that there is a higher frequency of massive breeding failure in a recent decade. So to summarize, what are the demographic processes by which sea ice affect the population dynamic of emperor penguin? It's complex and it depends on the time period. For example, during the dramatic decline of the population, it was related to an increased mortality due to lower sea ice condition, and after the population did not recover due to higher frequency of breeding failures that are probably related to fast ice extent. When I talk about Goldilocks zone of sea ice, I mean that the conditions need to be just right. Penguins need water opening within the sea ice to feed, but also seek stable sea ice as a safe platform to raise their chicks. So it's difficult to project what will happen in the future for emperor penguin given the complexities of those demographic processes by which sea ice influence the population dynamic. And this will also depend on the pathway of future greenhouse gas emission, and this figure shows the total carbon dioxide in the atmosphere according to time. And even if you probably already know that, I think this graph is very powerful when you realize that the x-axis goes back at least 3 million years ago. So it shows basically that today the carbon dioxide in the atmosphere is well above anything we have ever experienced as humans. And if greenhouse gases concentration continues their current courses, the carbon dioxide in the atmosphere is projected to reach 950 parts per million, and this is known as the RCP 8.5 climate scenarios. And these scenarios is recommended to be used for assessing the climate and future risk, at least through the mid-century, given that is presently known about biotic feedback and the current greenhouse gas emission path and the success of past forecasts to anticipate human behavior. By coupling a demographic model to climate output and sea ice forecast, used in the IP assessment report, we obtain projection for emperor penguin, and this figure shows a projection for one colony at Point Geology in Canterbury. So the black line shows the observed number of emperor penguins the last few decades, and the red envelope shows the uncertainties that are on all those population projections. And from this figure, it's quite obvious that the emperor penguin in Terre Adélie are marching toward extinction under a climate scenario of high emission. But we were hoping that it was not the case for all the emperor penguin colony around Antarctica, because sea ice is projected to change at different rate over the continent. And for example, in the Ross Sea sector, the projected loss of sea ice are smaller than in other regions. So we set up our analysis to look at what will happen for all emperor colonies around Antarctica, and this map shows the 54 colonies we have used in our analysis. Recent studies have updated the number of emperor penguin colonies around Antarctica to 61 using recent high-resolution satellite imagery, but those colonies are very small and do not contribute much to the global population dynamic. So this animation shows 3 panels that contrast the future for a world without or with climate mitigation. So the color and the size of the colony from the dots shows population decline by a target date, either 2050, 2080, or the end of the century. And on the right, most of these dots have disappeared under a scenario where greenhouse gases continue their current courses. This is the RCP 8.5 scenario that projects a global warming of 4.3 degrees Celsius. And in that case, 98% of the colony will go extinct by the end of the century. And importantly, the few colonies that will not have disappeared, shown in black here, will be declining. And because Antarctica holds the world emperor penguin population, this means that emperor penguins are marching toward extinction at the species level. In contrast, if the world will take aggressive action to reduce greenhouse gas emission and the Paris Agreement objectives are met, shown on the left figure here, variable emperor penguin refugees will exist in Antarctica by the end of the century. So the model still projects declines, but the trend will be much less severe and fewer colonies will go to extinction. So the scenario in the middle is a new climate scenarios accounting for the resiliency of sea ice while limiting uncertainties in socio-economic pathway by using 2050 sea ice level. We developed these scenarios in our more recent studies this year. And this optimistic scenario reflects the current windows of opportunity, demonstrating that even with immediate positive action, inherent lag in the climate system will continue to have impact on sea ice into the future. So in other words, by this scenario, we emphasize that even if humankind stop emitting any greenhouse gas emission today, the lag effect due to the atmospheric attenuation means that climate change will continue to affect sea ice well into the future. So under a new scenario, 2.6 degrees warming, that result from the current energy system trend and policy, the emperor penguin will be in danger of extinction throughout its entire range as well. So ultimately, the most important action to ensure the continued viability of emperor penguin is to rapidly reduce greenhouse gas emission to limit future warming. So it appears that the emperor penguin is now the proverbial canary in the coal mine that signals how society is acting to control greenhouse gas emission. The future of emperor penguins and much of life on Earth, including humanity, ultimately depend upon the decision made today. I strongly believe that scientists have a responsibility to make people aware of the need for change through objective science. Thank you for your attention, and with that I would like to thank all the volunteers that have participated to the acquisition of those amazing long-term data that allow us to document the impact of climate change. Thank you.
Thank you, Michelle and Steph. That was really exciting, but also really worrying science in terms of the predictions for emperor penguins. Could we bring the speakers back up on the screen, please? Thank you. Great. Jane, I'm going to bring you in now, if that's okay. But before I do that, just for our audience, both online and here in the room, as you listen to this final talk, could I invite you just to be thinking about some key questions that you might have? We'll have a Q&A straight after this. But Jane, if I can bring you in. So perhaps most importantly, we've just seen all this really astonishing science. So what are we going to do with it? What are the policy implications, at least from the UK government perspective? Thank you.
Great, thank you very much, Rod, and hello everybody. Thank you very much to my three previous speakers for their scientific oversights, and thank you also to WWF for organising this event. It is super important to raise Antarctica at COP. It may be far away, but as we've just heard, Antarctica, ocean and the atmospheric circulation. So if this COP doesn't deliver ambitious levels of change, Antarctica, in its melted form, will be coming to a living room near you. So last year, governments of the world came together at COP26 and adopted the Glasgow Climate Pact, which included new commitments to curb greenhouse gas emissions and to work to reduce the gap between existing emission reduction plans and what is actually required to limit the global average temperature to no more than 1.5 degrees C. So we are all eagerly awaiting the outcomes of COP27. There is no doubt that the fate of Antarctica and its surrounding Southern Ocean is largely in the hands of the United Nations Framework Convention on Climate Change. But Antarctica is also the only continent where nations have agreed to come together for its protection. 61 years ago, the Antarctic Treaty came into force to protect the continent for peace and science. 41 years ago, the Commission for the Conservation of Antarctic Marine Living Resources, CAMLR, was established to conserve the ecosystem of the Southern Ocean. And 31 years ago, the Protocol on Environmental Protection committed to protect Antarctica as a natural reserve and establish an indefinite prohibition on commercial mining. So what does all this mean for the fate of the emperor penguin? Well, whilst the future of sea ice on which the emperor penguins choose to breed is inextricably linked to global atmospheric and ocean temperatures, as we've just heard, there are all Antarctic treaty parties to play their part in the protection of this iconic species. Antarctic treaty parties are responsible for the protection of where the emperor penguins live and for the conservation of what the emperor penguins eat. So as we've just heard, the vast majority of known emperor penguin colonies are on sea ice. But there are one or two colonies on land, and recently some colonies found on ice shelves, as has just been explained. It is, however, far from clear that this can give us complete hope that these birds will be able to adapt. Ice shelves around Antarctica can be sheer cliff edges, sometimes up to 100 meters high, so flightless penguins have no chance of scaling such features. And finding low-level ice-free land around the Antarctic continent is equally challenging, because many of such areas have already been colonized by other species of penguin or have been chosen as locations for Antarctic scientific research stations. In terms of emperors feeding, as we've heard, they mainly eat fish, including Antarctic silverfish and squid. And like many animals of the Antarctic ecosystem, the small, but many would say mighty, krill is also critical. They forage for food over 500 kilometers from their colonies, and whilst there's no commercial fishery for silverfish or squid in the Southern Ocean, interest in krill fishing is increasing. Whilst non-climate related threats to the future of emperor penguins as a species are currently considered as relatively small, if not negligible, there are potential threats to colonies at a local level, particularly from the construction of infrastructure, scientific activities, or human visitations, be that by tourists or scientists. And some forecast tourist numbers to the continent this year to exceed 100,000 for the first time. So the UK has been leading a proposal supported by many nations for the Antarctic treaty parties to designate the emperor penguin as a specially protected species under the Environmental Protocol. This would secure the implementation of an action plan to reduce and, where possible, prevent threats to emperor penguins and their habitats at all stages of their life cycle. The draft action plan sets out a range of measures that could be taken, including strengthening guidelines for visitors to emperor penguin colonies, for the use of drones over colonies, and for scientific activities on the birds. Currently, 8 Antarctic specially protected areas have been designated with emperor penguins at the primary value. But the action plan also proposes developing management tools to regulate human activity in the vicinity of every emperor penguin colony, and to restrict access entirely to some, including those that have not yet been visited by humans, and especially those that are representative of climate change refugee populations and genetically distinct metapopulations. Sadly, however, despite very clear advice from the international science community, stated clearly by the Scientific Committee for Antarctic Research, that the emperor penguin is indeed projected to undergo a rapid population decrease as climate change results in Antarctic sea ice being thinned and reduced in extent. There was no consensus at the last Antarctic Treaty Consultative meeting that the species should be afforded specially protected species status, and for this proposed action plan to be adopted. China explained that their position related largely to the emperor penguin not yet being classified as vulnerable by the International Union for Conservation of Nature, the IUCN. But further scientific information regarding the current status of emperor penguin, coupled with revised climate impact assessments, suggest that this IUCN classification could soon be revised. And we hope, therefore, that the next Antarctic Treaty Consultative meeting might come to a different conclusion. Whilst, as I've mentioned, the risk to emperor penguins from commercial fishing is considered minimal, the Commission for the Conservation of Antarctic Marine Living Resources also needs to play its part on ensuring that this remains the case. The agreement in 2016 of the 1.55 million square kilometre Ross Sea region marine protected area provided additional protection to more than a quarter of the world's emperor penguins. But proposals for additional MPAs in the Weddell Sea, which was, as we've just heard, is an important region, and East Antarctica, would provide additional protection for the species. But these proposals have been locked in limbo land for several years. Most members of the CAMLR Commission are keen to make progress on designating new marine protected areas, and there should be a special meeting of the Commission in the first half of next year to try to make some progress. Antarctic Treaty Parties also have a responsibility to communicate the importance of Antarctica and the animals that call it home on the welfare of the rest of the planet. As we have heard, Antarctica is inextricably linked to us all. Understanding the implications of global climate change on Antarctica therefore matters to everyone. The polar community is striving to ensure that everyone who works on Antarctica feels safe, respected, and free from discrimination, and we are keen to encourage a vibrant diversity of all the talents in polar science, law, policy, and logistics. So it's even more of an honour for me today to be on such a female-dominated panel. Understanding Antarctica is key to understanding how we can best protect the emperor penguin. So together we can and must seek to understand, assess, and mitigate the threats to this iconic species. I do not want to think of the next generation growing up without it. Thank you.
Thank you. Thank you very much, Shane. I fully share all your sentiments expressed there, and you know, it's just astonishing to think that the fate of this species rests in our hands, rests in what's happening here at COP, but also at other international forums like the Antarctic Treaty System. So thank you. I'm going to open up to a Q&A now, questions and answers from the audience. We've lost some of the audience due to the technical glitches, but we still have a great quality audience here. So if I can invite you to ask any questions, but if you would like to ask a question, could I please ask you to say who you are and who you're representing? And yeah, Chen, can you manage the microphone? Thank you.
Yes. Can you hear me? I can't hear myself. All right. Hello. Hi, everybody. Thanks. I'm Jessie O'Reilly, Indiana University and Antarctic and Southern Ocean Coalition. Thank you very much to these experts across all these time zones providing us information about this. I have questions for this, the penguin biologists and the Janes. So my question for the two Janes is about policy, and I observed and note that we failed at the Antarctic Treaty meeting to protect the emperor penguin, and Jane Rumble, you described some steps forward and perhaps some new information, and so I'm wondering what's next. I found it really disappointing that the Antarctic community couldn't protect our really emblematic species and also one that's clearly threatened. So I'm wondering what the timeline and perhaps the strategy for approaching IUCN about the emperor penguin's change in status. The other question is to the biologists, Michelle and Stephanie. Thank you for that. Reading the most recent IPCC report, they stated that the RCP 8.5 scenario is now highly unlikely because of the trajectory that we're on. It's way too slow, but we're not headed up that curve that we were. We're doing something. And so I'm wondering, as I was looking at this information, if you have information about thresholds or tipping points at lower degrees of warming. I am fully behind supporting the emperor penguin and doing everything we can as fast as we can. But I'm wondering if we know anything about the temperatures in between now and the 8.5 that might show us what operating space or timeline we're working under. Thank you.
Thanks, Jessie. Can I just check, did the panelists catch all the questions? Yeah, I'm seeing nodding heads. Thank you. Okay, so should we start with the policy question there about IUCN? Jane, thank you.
Yeah, thank you very much. Hi, Jessie. Well, firstly, I should say that, of course, the emperor penguin is protected by the environmental protocol. So what we're talking about here is additional protections and the implementation of a management plan, which we still think is important. My understanding is that there is new scientific information about the extent of emperor penguin decline, and that this should help to move the classification status within the next IUCN meeting. Of course, in my presentation, you will understand that only one member of the treaty community considered that this was necessary, but given that they've stated that it would be necessary, we hope that could happen soon, and then we will be resubmitting the proposal for the extra protections at the next Antarctic Treaty Consultative meeting, which takes place in Helsinki in May 2023. So, fingers crossed. Thank you.
Thanks, Jane. Thanks, Jane. And Michelle or Steph, which of you would like to respond to the science question, or both of you would like to? Who'd like to go?
I can start. So for the RCP 8.5 scenario, it's considered as a high emission scenario, and it has been debated mostly because those high emission scenarios after 2060s are considered perhaps unrealistic, given that with climate change, perhaps the economic will slow down, and this scenario basically assumes that the greenhouse gas emission continues their current course. But actually, when you look at the number now, we are on this predicted CO2 emission pathway. Anyway, if you look, it's exactly why we developed this scenario in the middle of the map, have shown what I call the 2.6 scenarios, because it's the scenarios that basically said that we project the sea ice decline up to 2050, where there is much less uncertainty in the socio-economic development. And then I say, from 2050 to 2100, the sea ice remains the same, because it has been shown by climate scientists that even if you stop all the CO2 emission, sea ice will take a long time to recover and take about 50 years. So this is why, assuming that the sea ice will remain the same at the level of 2050, it's realistic scenarios. And even under these scenarios of 2.6 degrees warming, you have the population that is declining dramatically, and the emperor penguin march to extinction. And I'm sorry, there was a problem with the recording, but on the last slide that went very fast, we also showed that there was basically a linear relationship between the threat of extinction and the warming. I don't know if you remember the figure with the penguin marching. And so you really need to hit the Paris Agreement objective if we want to avoid the threat of extinction for emperor penguin.
Thanks, Steph. Michelle, would you like to add anything to that, or are we good with that?
I think we're all good.
Great, thank you. Emma, do we have any more questions online first? No? Okay. Yes, please.
Hi, this is Mark Urban from the University of Connecticut, and this is for Stephanie, I believe. So you might have said it was a little hard to hear some parts of your presentation, but I've been arguing for many years that species interactions are often more important than the direct effects of climate change, and it wasn't clear the degree to which their food resources were included in your models, and if they are included, what's our uncertainty regarding those changes, and would it impact your model positively or negatively, do you think?
It's a very good question. Unfortunately, we have to work with long-term data to be able to detect and attribute the effect of climate change. So we work with this 40 years of data, and emperor penguin eat krill and fish, and we don't have such data at the colony, for example, in pongology, where we have made correlation between change in sea ice and change in the demography of the penguin. So basically, it's kind of a black box here. We have sea ice, we have the survival, reproduction, and life cycle of the emperor penguin in the model, but we don't have all the species interaction between sea ice and emperor penguin, and definitely not the one with krill and fish. And I agree, it will be very important to account for, but at this stage, we just don't have the data available to do so. And I don't think we will have even in the near future, because this will require to have oceanographic campaign measuring krill and fish abundance on the penguin foraging area in the middle of winter, which is just technically impossible right now.
Thank you. I'm just looking around the room. Any further questions for our panelists? Yes, please, at the back. Thank you.
Hi, my name is Brady Hill. I'm with Johns Hopkins University, and I had a question for Michelle. You were discussing utilizing satellite imagery and data to track colony movements and get a sense of population size. Is there any, from your understanding, is there any gaps in that data set as far as coverage or frequency or resolution that you all would like to see more in the field, or do you feel like the current data that is provided is adequate to get a good assumption of those populations?
Good question. Obviously, my answer is always, more data is always better. But the high resolution imagery kind of came online in around 2005 or so, and we didn't really start acquiring imagery until about 2009 routinely. And so as we've been kind of surveying the whole coastline year after year, we're filling in the gaps where in between some of the colonies. So I would say that I'm pretty happy with the overall coverage. We now know that there are 61 colony locations, and half of which have been discovered using the high resolution imagery or Landsat imagery. And so I think I would understand, I think that probably we're good as far as the coverage, but now it's a matter of getting it over time and really being able to see the dynamics over the course of generations, which of course is just going to take some time. At the moment we have coverage for about 10 years worth of data for the 54 colonies that Stephanie mentioned. And so now we just need to continue waiting to see what the colonies end up doing in the future.
Just one final scan of the room for any more questions, or Emma, anything online? No, I think we've exhausted the questions. So let me just close by acknowledging that the climate crisis and the nature crisis are global challenges. They're of course bigger than any one region here today. But there's this incredible opportunity here in Sharm el Sheikh for world leaders to really raise the ambition, and for governments and businesses across the world to meet as we won't forget, and future generations are not going to forget. So with that, I'd just like to thank the International Cryosphere and Climate Initiative for hosting our event today. I'd particularly like to thank our amazing speakers, our four speakers, who I think deserve a very loud round of applause. And I'd also like to thank the audience for bearing with some of the technical issues and the fly infestation and everything else that's been going on here today. So thanks everyone, I really appreciate it. Thank you.
Thank you, Rod. Thank you very much. We now will close this event. The next event will be on climate change attribution everywhere, every day, scientific advances and communications will be begin very shortly. Thank you.